Okay, thank you for joining us once again for this Broadband Forum webinar around the subject of QoE in a wireless wireline converged network. We're lucky to have today joining us people representing companies such as Ericsson, Juniper, and Deutsche Telekom. And this work is around our wireless wireline convergence work area group. So just like to set up a little before we go through the agenda. I just want to open up with a little bit of housekeeping, just to let you all know that we are recording this session, and a download of that recording, as well as a PDF of the slides, will be available post-event. We'll send a link in an email to you if you accepted our request for further communications. One other piece of housekeeping is that we will be driving a Q&A session at the end of this webinar. If you do have questions for our panelists, then please can you put them in the Q&A tab. Now that can be found in the middle bottom of your Zoom window, and that gives you the opportunity of putting a question in the Q&A tab. And to help the moderator, myself, if you could also maybe just indicate who you're asking the question to. Because we are lucky today to have some expert panelists from major contributors within the WWC work area, the wireless wireline convergence work area. So that's Dominik Czajka from Deutsche Telekom T-Mobile Poland, who has been supporting and contributing to a number of pieces of our work within the Broadband Forum and WWC. Venkatesh Paddebattu from Juniper Networks, who is a project stream leader within our 5G WWC group. And last but not least, Dave Allan from Ericsson, who has been a foundation cornerstone to a lot of the work that we've done in the BBF, and especially recently within WWC. So, gentlemen, thank you very much for joining and being a panelist on our webinar today. Okay, just quickly on the next slide to look at the agenda. Well, first of all, just going to have an update from Dave Allan on our WWC work and an overview of what's been going on. Then we'll be moving on to Dominik, who's going to be talking about 5G and wireless wireline convergence end-to-end QoS. And then finally, Venkatesh will be talking about the VBF Converged QoS and QoE in a slightly more technical, deeper dive. And as I mentioned before, we'll then summarize and move into a Q&A. So after all of that information, you've heard enough from me. Let's leave it to the experts, and I'm going to pass over to Dave Allan.
Thank you, Craig. And can I get the next slide, please? So wireless wireline convergence is a project requested by a group of major operators that kicked off in 2017. The intent is to allow wireline subscribers to be served by the 5G system. The goal was to specify any required changes to the 5G system to support this, and for the Broadband Forum to generate a corresponding set of specifications. The 3GPP changes were to be incorporated into the Release 16 work. This turned out to be a big task, primarily because due to the nature of fixed access. As each served area is self-contained, and there is no requirement for ubiquitous mobility, there was no one architecture. Defining a path to 5G convergence that addressed all operator sensibilities with respect to investment patterns, operations, and so on has been a big task. We've just published the second set of specifications, more on this later, and we're continuing to incorporate more and more 5G technology and use cases into our work. Next chart. This is a high-level architectural view of wireless wireline convergence. It illustrates the basic deployment scenarios. On the left, you have various flavors of CPE, either legacy or 5G enabled. The 5G enabled CPE can support wireline, wireless in the form of fixed wireless access, or both accesses for hybrid, either for resiliency or for bandwidth aggregation. And this, of course, depends on how the CPE is equipped. Wireless access is specified as either 4G or 5G, as we expect the transition to ubiquitous 5G radio everywhere to occur over a fairly long period of time. In the middle, we have an unmodified access network, the optical line terminations and DSLAMs. There are a lot of scenarios where this may be a third-party access network, or there are significant barriers to upgrade. So the unmodified part, and I put that in quotes, was a key requirement to maximize the deployable footprint for 5G convergence. Connecting the access network to the 5G system is the access gateway function. This is a mediation platform where the magic happens, where we shovel coal in and we get 5G out. It supports both 5G enabled and legacy CPE in simplifying network transformation. And finally, you have the full-blown 5G system with subscriber management, policy charging, network exposure, and lots of other good stuff. Next chart, please. So the benefits of convergence are pretty well understood at this point, which is why it's been a bit of a holy grail, but one that's been unattainable for a myriad of reasons. The fact is that everything else is converged. And this means that most of the barriers to convergence have faded away, putting true convergence finally in reach, and all that good stuff is looking increasingly tempting to our operator community. So I've got a list here, but rather than just read it, I'll toss in a few things you may not have thought of. For example, the benefits of a common function inventory and how that extends to all aspects of the business. Onboarding, testing, training, troubleshooting, etc. Getting to a common QoS model means a common charging model, common service assurance, and a common expectation of your subscriber independent of the access. It also allows you to get to meet all of your regulatory requirements with a single system, so common legal intercept, common voice services, etc. The list goes on and on and on. Next chart, please. So we had some specific themes we focused on for the second issue of the Broadband Forum specifications for wireless wireline convergence. As I'd mentioned earlier, there is no single access architecture out there. So we focused on expanding the number of starting points that had a clear path to 5G convergence. This involved dealing with things like MTU issues, deployment models, and the like. At the same time, we also looked at expanding the service functionality available to 5G operators. This included hybrid access, network slicing support, various additional use cases to help monetize the network further, and of course, increased personalization of services. Next chart, please. So we've just published issue 2 of the wireless wireline convergence specifications. Now, issue 1 of TR 456, the AGF requirements document, covered all the fundamentals of both legacy and 5G RG support. What issue 2 does is it expands the support for legacy CPE in the form of multi-session support and expanded legacy authentication and credential models. It also addressed other operational aspects such as MTU handling, QoS marking, improvements to NAS transport and reliability, and QoS enhancements in general. Issue 1 of TR 470, our 5G WWC architecture document, it contains a lot of the why information as to how wireline was adapted to 5G, as well as detailing some common aspects of the work. What issue 2 does is it adds some new use cases, some enhancements and corrections, and simply keeps the document and that very important understanding and background description up to date with respect to the work overall. TR 124 issue 6, the residential gateway requirements, brought forward the basics of supporting a 5G RG. Issue 7 covers the RG aspects of multi-access support and specifies the RG end of the various operational enhancements that we embodied in the issue 2 work in general. Next chart. Now, WWC, of course, is a moving target, just as technology is and always has been. For 2022, the Broadband Forum is working on convergence of voice services. We have a project to do an open source support for a 5G RG to expand the food chain. We want to expand the deployment options with the specification of the FMIF, the Fixed Mobile Interworking Function, which is an additional mediation platform to allow 5G services to be offered to subscribers that are directly connected and served by BNGs. And we're doing the control and user plane specification for the AGF, which is the 5G version of software-defined networking. And the Broadband Forum work on 5G is not just confined to the convergence aspects. Projects either directly related to 5G or producing technology that complements 5G includes work on transport architectures, how the underlay integrates with or simply complements the 5G system, performance monitoring tools, where there's been a lot of development and a lot of thought there. The Broadband Forum is leading the work for control and user plane separation across the access, not just for 5G itself. And we're driving increased levels of service intelligence in the residential gateway. Next chart. So while there's a lot going on, for today, we want to focus on the quality of service and quality of experience aspects of the 5G system. We have two excellent and knowledgeable speakers lined up, and as I've already taken up too much of their time, I'll stop here and turn over to my esteemed colleague, Dominik.
Thank you, Dave. And please proceed to the next slide. Hello and good day, everyone, regardless of the time zone you are in. I would like to take you for a short trip into the quality of service world. Our main focus would be how end-to-end quality can be assured throughout the systems owned by the ISP and how it secures seamless service realization. The first topic on our road would be QoS handling, defined inside the 3GPP standards for the 5G world. And from that, we will move to discuss VBF defined additional sorry, the previous slide still. We'll move to discuss the BBF defined additional components that are needed for end-to-end QoS assurance in wireless wireline converged systems. So please fasten your seatbelts and let's take off. And now next slide, please. Okay, to understand 3GPP approach, we must get familiar with some basic concepts. First of all, the user plane realizing data transfer consists of three main components: the user equipment, radio access network node, and user plane function. To secure end-to-end QoS, each of these components needs to be aware of QoS characteristics and be able to steer them. Subscriber data is encapsulated inside the protocol data unit session, but individual packets sent in 5G system can be mapped to even smaller entities called QoS flows. Each QoS flow is identified by the QFI value. When it comes to relation between PDU session and QoS flows, it is one-to-many as shown on the diagram. While each QFI represents requirements from session perspective, there is also a need to consider radio propagation parameters. And for that purpose, the data radio bearer was defined. It tunnels packets associated with specific QFIs, providing control of QoS characteristics throughout radio access. Each QoS flow can be mapped to only one DRB, but multiple DRB can be utilized to transport packets related to the same PDU session. Depending on the requirements of service offered, QoS flows can have one of three types. We can have guaranteed bitrate for assured quality services, non-guaranteed bitrate for best effort services, and delay critical reserved for mission critical services. When we move to the next slide, we will see the representation of the granularity that QoS flows offer. Please proceed. As you can see, each individual service can be assigned unique QS flow with corresponding QS characteristics. We can distinguish between best effort internet browsing and video streaming requiring higher throughput. But also 5G World enables us to separate different conference application packets and assign them desired parameters. And for that purpose, 3GPP introduced two-layer mapping performed by the 5G system. So in short, each packet coming to the 5G system is filtered and assigned to the QS flow by the non-access stratum filter in the UPF. When it gets delivered to the radio access network component, in this case Gnode or eNodeB, it is mapped once again, this time to the adequate data radio bearer based on the assigned QFI value. In the uplink direction, it is user equipment's role to perform both packet mappings. It is non-access stratum and access stratum. On the next slide, we discuss in more details the NAS filtering mechanism. Please proceed. As already mentioned, each incoming packet is filtered and then matched against existing packet forwarding control protocol session, in short PFCP session. When that session is found, in the next step, packet detection rules are checked to find fitting one with highest precedence value. PDR rules contain so-called packet detection information that defines matching criteria based on interface, QFI value, and traffic information elements. Each of those PDR rules also contains instructions for packet processing, and after successful matching, those instructions are applied. Most important in our case is forwarding action rule, FAR, that contains information on whether forwarding, dropping, or buffering is to be applied to detected traffic. Other rules that can be used are URR, the usage reporting rule. It informs how traffic shall be accounted, as well as how a certain measurement shall be reported to the 5G system. We can have BIR, buffering action rule, describing buffering mechanism, QS enforcing rule, QER, which brings information related to QS enforcement, multi-access rule giving details of how to handle traffic steering, switching, and splitting. And lastly, there's also session reporting rule that defines how to detect and report some special events not mentioned previously. Please proceed to the next slide. Okay, as we already know how the traffic should be handled, it is time to discuss how QS rules are distributed in 5G system. Policy and charging control rules are the source of all processing information and are provided by the specialized dedicated function called Policy Control Function, PCF. From that element, PCC rules are forwarded to the Session Management function, which binds those rules to the existing QS flows. SMF is responsible for the delivery of QS parameters to the corresponding user plane elements via appropriate interfaces. As you can see, SMF has no direct communication with user equipment and radio access network, so it communicates via AMF. Each user plane element gets relevant information inside defined data model, like QS rules for UE, QS profile for Gnode or eNodeB, and SDF template for the UPF. On this slide, we can see some exemplary control information that are produced by the PCF. Those are the uplink or downlink maximum and guaranteed bitrate, some priority levels, or so-called 5G QS identifier. And I would like to focus on the 5QI as it is a standardized container for QS characteristics information. So on the next slide, we have some more on that parameter. Please proceed. Okay. 3GPP introduced this 5QI for quick traffic classification and provided multiple standardized purposes for it. Each identifier contains priority level and QS measurement parameters that must be met for a given traffic type. On this slide, we can see examples of the service classification, like, for instance, voice service with 5QI1, the video live streaming with 5QI7, or autonomous car communication with 5QI83. And here, once again, we have distinction between guaranteed bitrate, non-guaranteed bitrate, and delay critical services. Each QS flow has a mapping to 5QI value, which gives the system required information to handle traffic related to differentiated services. 5QI would also be important for maintaining end-to-end quality of service in our converged system. And with that comment, we proceed to the second part, where we mix mobile world with wireline access. So please show us the next slide. Okay, so at the BBF, we like the layered approach, and as such, the QS model is treated. We have 3 layers. The wireline transport is the third layer of the QS mapping. To maintain quality of service throughout the wireline transport layer, 2 VBF components have been introduced as translators between mobile and fixed world. AGF and 5G RG provide the mapping between 5G wireless wireline convergence user plane encapsulation, called in short 5WE, and the QS flows that we already know about. Those 2 elements also ensure that 3GPP parameter values are maintained throughout the whole session. So let's see our VBF components in action on the next slide. So, okay, there's an incoming packet from 5G system for a user. UPF sends it via GTPU tunnel for each PDU session. In the GTPU header of that packet, AGF can find information of associated QFI and possibly reflective QS indicator. This information needs to be preserved while encapsulating packet in AGF into the 5WE. Also, PCP and DSCP information needs to be applied for our wireline access. After that step, bitrate limiting takes place, followed by shaping and queuing of the downstream. After preparing all the parameters for downstream tunnel, AGF sends the packet to 5G RG, which applies reflective QS if indicated. In the other direction, similar mappings are performed by the 5G RG. First, 5G RG needs to determine 5G QS parameters for the uplink traffic. After that, it can perform the 5WE encapsulation, while of course preserving QFI values. Limited, shaped, and queued traffic is transmitted via single tunnel to the AGF, where it is aggregated, encapsulated into the GPU tunnel, and after that forwarded to the user plane function of 5G system. So for all that magic to happen, 5G RG and AGF need to be informed about mapping mechanism between 5G defined parameters and wireline transport parameters. So let's move to the next slide to describe that provisioning. Here we can see the Converged QS Provisioning that contains additional wireline specific QS information that needs to be provided to the 5G RG and AGF. Decision engine stays the same, it's still the PCF, and the model just needs to be expanded to cover that additional information, which is presented in a green color. RG level wireline access characteristics, so RGLBack data model contains essential data for AGF, including mapping between 3GPP 5QI values and wireline DSCP PCP marking. Also, it contains some more information like the bandwidth profile or the shaping and policing configuration. This information is sent during user equipment context setup and may be updated later on when the session is ongoing. And that would conclude basics of the end-to-end QoS in converged network architecture overview. Please present us the final slide. Okay, so there are 3 things I would like you to remember from my part of presentation. First, the 5G WWC quality of service model is fully compatible with 3GPP defined characteristics due to support introduced in 5G capable residential gateway and wireline access gateway function. Secondly, this model reuses already existing wireline transport layer mechanisms, so there is no need to change transport infrastructure or technology. And the thing that all can benefit from is that QoS model provides full ownership and control of the QoS from the customer household to the provider's deepest nooks and crannies. And well, that would sum up my part. Thank you for your attention, and please allow me to clear the floor for our next speaker, Venkatesh.
Hi. Hi. Hello, everyone. Good morning, good afternoon, good evening, wherever you are, and hope you all are safe. Thank you, Dominik, for the excellent information on the way the QoS is handled in the wireless networks and how it is mapped to the wireline wireless convergence. In the next few slides, what I would be doing is I'll take a bit deeper dive into the details of the tools which the WWC 5G project stream provides to improve the quality of experience in the wireline wireless converged use case. Next slide, please. To provide seamless internetworking of wireline and wireless conversion, it is essential to guarantee consistent end-to-end service level agreements and cost requirements. For example, bandwidth, delay, jitter, packet loss, and over the heterogeneous access networks and the core networks. Different wireline access networks like fiber, DSL, and cable, etc., have different cost concepts. And these cost concepts have been implemented in different ways and approaches, right? And the one expectation when we see, which comes from all the service providers, is even with all the differences of the different types of access networks, the expectation is to deliver a converged 5G cost to all the subscribers and irrespective of what is being done on the access side, right? So that becomes one of the important goals of the 5G project stream in the Wireline Wireless Convergence group of BBF to come up with a model, right? Or the right set of tool, the tool which can provide this mapping. So the BBF standards, what I think Dave covered it, and also to some extent Dominik, but we provided 3 sets of documents in the last 1 year, which are the second issues or the newer issues of the documents, wherein the 470, the TR 470 provides the overall architecture of the wireline wireless and details on how the end-to-end cost can be achieved. The TR 456 issue defines the functional requirements and how the wireline wireless cost can be glued to the wireless cost and provide a seamless user experience, right? The TR 124, the issue 7, which is the latest, provides requirement on the 5G RG to be, to work with AGF, right? So in the last few slides, Dominik was talking, right? So how the 5G RG and the AGF have to work together to provide the cost. So the TR 124 provides you the requirements on the 5G RG itself. Next slide, please. This slide provides an overview of the different actions performed in different entities involved in the. Dominik covered this at a high level. I will go by just one more level deeper to give you an idea on what happens at this. So If you look at the 1 and the 6, right, the UE and the UPF, these are the entry points of the packet in the upstream and the downstream direction respectively. Per PDU session, each flow is mapped to a 5QI value, which is this 5G QoS indicator, and which actually defines the characteristics of the flow. This information is provided to the UE and the UPF via, and along with the other attributes of how this particular flow is handled from the 5G code when the PDU session. I would say you can imagine a PDF, people from the wireline background, you can imagine a PDU session to be an IP session with the UE having an IP address, which is used for accessing the core network or the internet, right? The UE in the upstream direction and the UPF in the downstream direction are responsible for identifying the flows based on what you call as a packet characteristics like source IP, destination IP, the file tuples, etc., and map it to the right QFI and attach it to the packet, right? The UPF puts it on the what you call as the GTP tunnel, and the 5G RG is going to put it on the 5WE encapsulation to identify the particular flow. So and the G node B, which is also represented in this diagram as the AN, right, is responsible for making sure the correct transport level marking is done towards the UE and the UPF in both upstream and the downstream directions. So when the G node B encapsulates the packet in the GTP tunnel, it actually goes on an IP network or an IP MPLS network. So it has to do the right transport level marking so that the packet gets the right preference over the network to reach the UPF itself. UPF is again responsible for making sure that the right transport level marking is done towards the G node B on the GTP tunnel. When we see the cost, right? So if cost can be divided at a very high level into two, making sure that the right transport level marking is done and also the right enforcement, right? So if we have what you call as a guaranteed bit rate or MBR information which has to be applied, the per PDU session enforcement is the responsibility of the UPF. So when the UPF actually confirms, identifies the cost flow and identifies, so it actually enforces the different GBR or MBR, which is provisioned on for that particular flow for the session. And that's how what happens is you see the end-to-end cost is being implemented in case of a wireless world. Next slide, please. Now, for folks, I think, who are familiar with the wireline access models, it is pretty obvious what happens in case of a wireline, right? So most of these functions, which in case of wireless, which are split between the G node B and the UPF, are concentrated mostly on the BNG itself, which is the broadband function, right? So if you see in this slide, you see the CPE is basically configured with whatever is the L2, L3 transport level markings, and those are set based on the application or however it is configured on the CPE, and the packet is sent from the CPE to the access network. The access network, which could be a fiber, cable, or whatever, have their own mechanisms of implementing costs, but what they actually look at is the L2 or sometimes even the L3 priority, which is the IPDSCP values, to provide what you call as priority handling of packets wherever there is a congestion. BNG, again, is responsible for making sure that the right transport level marking is done towards the core network and for the upstream direction, and also for the downstream direction towards the CPE or the residential gateway. The one thing, right, which we also expect, and is then the packet is coming from the core network. The core network is actually providing you some level of transport level marking so that the packet is prioritized in the right way in the in the core network itself. So the core network is responsible for setting the right marking values. BNG is responsible for setting the right marking values. The CP is in the relevant directions. But the enforcement of the cost rules like CIR, PIR, which are more common, or terminologies on the broadband side, the confirmed information rate, the peak information rate, is all applied on the BNG, the police in form of policers, shaping, scheduling, and all those. So if you see, the most of the concentration of the cost functionality is in the BNG. Right. Next slide, please. Now, Dominik gave us a very high-level overview of the new tool which was introduced in TR 456 and TR 470, which is the RGLBack, which is the RG level wireline access characteristics. As the name clearly mentioned, it is actually providing you the information, or the AGF with the information, how to map the 5G or the 5G cost identification elements like 5QI and QRFI to the wireline specific parameters. For example, now you have a 5G RG connected over a wireline interface to an AGF. Someone has to indicate the AGF that, okay, I am sending this packet on the 5WE interface. What would be my 802.1 1 qubits, which is the PCP value, so that it gets the right priority in the access network, whether it's an OLT, ONU, or the DSL, whatever is the network which is there. So the RGLBack provides you such information, and also it provides you an aggregate information which is very similar to the AE-MBR in case of genoding. What RGLBack is provided with is information which can be applied for the complete RG, irrespective of if it supports multiple PDU sessions or single PDU session. This is, for example, you want to say that, okay, this RG in total provides you a 10 Mbps guaranteed, 10 Mbps CIR or a PIR, and this information is provided to RGLBack, and it is the responsibility of the AGF to enforce this information for that particular RG. Dominik also mentioned the way the RGLBack is communicated to the AGF, right? And whenever RG registers to the 5G core, then RGLBack is provided in the initial UE context IEs. And also, similar to what we have in the BNG today, like CoA, a RGLBack can be modified at runtime using UE context modification messages. And this provides you the similar flexibility what we have in the BNG for updating the cost rules or whatever. Going into a bit more detail on what the RGLBack defines is, the way RGLBack has been defined in TR 456 is, it has been defined so that each and every parameter which is responsible for the cost on the wireline can be explicitly called out, or the flexibility can be at a summarized level wherein you could refer to a policy configured on the AGF. So the versatility is that, okay, you have an existing policy which you know how your wireline network works, and you have a defined policy for it. So the RGLBack could just refer to the policy, or you have the granularity of defining each and single item, like the way we have the radius VSAs or similar in the BNG, to dictate or override the local configuration in the AGF for a particular for a particular parameter of a PDU session, right? in a way, like the other aspect which RGLBack also takes care is, so when a 5G RG connects to the AGF or the 5G core via AGF, it is coming on the wireline connectivity, and there is a wireline access. So the 5G core using the NAS signaling or the NAS signaling provides you the different QFI and the 5QI values to the 5G RG. But when the 5G RG packet actually goes out on the wire, the information which it has to set, like the IP DSCP, and is communicated in the session parameters of the RGLBack. So the RGLBack provides two, at a summary level, right? It provides, or it gives you two set of information. One is the enforcement information for the AGF itself for a particular residential gateway, and also the information needed by the residential gateway to set the right priority of the packets on the wireline access. Next slide, please. On the right, in this diagram, so this is exactly what I was just now trying to say, right? So the wireline cost characteristics, the PCP classes, the 5QI mapping to the PCP DSCP, and also the cost TLVs. The first set is actually the ones which are enforced on the AGF, and the second set is the ones which are communicated towards the 5G RG. One thing here, right? We, in the most of this discussion, what we have seen is the mapping, right? The mapping of the 5G parameters or identifiers to our broadband parameters or the wireline parameters. The important piece is that they are glued in the right way to achieve the end-to-end QoS, right? So the mapping of the QFI, which is provided between the UPF and the AGF, should be able to translate into the right priority between the AGF and the 5G RG in the downstream direction, and the same, the parameters provided for the upstream direction to the 5G RG map to the right service parameters which are provided by AGF to the 5G RG for the packet, map to the right parameters between the AGF and the UPF. And that's how we will be able to provide the end-to-end cost as defined by the 5G system, and with a single point of control. And with that, I hand it over to Craig. Thank you all.
Venkatesh, thank you so much. I appreciate that, and I appreciate all of our speakers. Thank you very much. So I just want to do a very quick summary before we move into the Q&A. And first of all, if we move to the next slide, please. So you've seen this graphic before, and this is an infographic that we're using very much for an overview of our WWC work. And at the bottom, we're looking at Converged core rich feature sets, where within the joint work that we're doing with the 3GPP, we are taking the Converged core and creating that rich feature set that can commonly applied across many areas, such as policy, charging, access sharing, real-time fulfillment. We've heard a great deal about the quads mechanisms and mapping and personalization, as well as network exposure and the opportunity for network slicing. So basically, this is driving the opportunity for a common control plane that it's extended all the way to the premises. And if you build to the next point, please. So the next major key point of our WWC work is this dual mode access evolution, where the wireline and the 5G mediation via dual mode AGF and or from the BNG FMIF interaction can enable a smooth and evolutionary transformation, basically allowing you to plug in anything and supporting it across the existing fixed access assets, such as your existing DSL network, PON, fiber networks, as well as wholesale networks. The next bullet point, please. So then if we're looking up this tab, we're looking at the 5G toolkit, and we've just already gone into basically a whole deep dive on how we can map QoS across the mobile to the fixed line network as well. Basically allowing us in release 2 to help wireless QoS mapping to be uniform and consistent across both of those wireless and wireline networks. And then finally, we've touched upon in previous webinars as well as today, the ability to have a multi-gen 5G RG, as well as a fixed network residential gateway enablement, whether that's 5G fixed wireless access, as well as wireline residential gateways. Basically offering us the ability to have within the WWC group to incorporate all the capabilities from the 5G toolkit into our specifications and to realize a variety of use cases. Now, those use cases can range across many areas, such as enhanced working from home, a hybrid access model, access sharing scenarios, and a convergence of voice within a traditional voice within the mobile system. This work is really allowing us to converge operators to provide a uniform experience to their customers, irrespective of the access or appliances that they are using, supporting a common and streamlined back office and control plane. So that's basically a 2-minute overview of what we're doing and our goals within WWC. But what is the next steps? What are we going to be doing within our Wireline Convergence group next? Well, first of all, we've released 2 this year. We've actually just got a press release out today announcing that release 2 success and publication. And we are not stopping there. Release 3 and work on release 3 has already started, and we've got some exciting new updates, new use cases and projects involved in that. Now, one of those main projects is a new project stream around IMS for residential gateways. The plan in this project stream is to work on how we can integrate traditional voice services that we've seen across the fixed network, which often could have been regulated, and how it looks across a converged 5G network and wireline network. Now, from that perspective, if you want any more information on this brand new project stream, please do reach out to our work area directors or Martin Taylor of Microsoft, who has taken the lead and the project leadership role within this new project stream for IMS for residential gateways. And then finally, our open broadband work entitled OB5WWC is really gathering pace. Now, this is an open broadband software initiative, so it is very open to Broadband Forum members to contribute, but also non-members can sign an NDA and also be part of that contribution. So you don't even have to be a Broadband Forum member to help us contribute in OB5WWC, which aims to create a reference implementation of the Broadband Forum specifications that you've heard today, to look at that reference implementation solution for a 5G capable residential gateway. So building really on the important work that we're doing here within the forum, as well as the co-work that we're doing with the 3GPP specifications that are already. Okay, so that's really a summary. Thank you for your time. I'd like to now move into a Q&A session, if I may, in the next slide. You've been very busy, and thank you very much for your time in putting questions into that Q&A tab. And I'm going to kick it straight off. And Dave, maybe you'd like to answer this one. Can you please explain more on 5G RG support? Does it mean the RG only uses 5G as its WAN connection, or the 5G as the secondary to its fiber connection?
Okay, yeah, I kind of realized when I was doing my part of the talk that was going to need a bit of clarification. Basically, a 5G RG is one that is an RG that will use 5G procedures on any WAN interface that it has to manage its connectivity. So you extend service fulfillment, and the full capability of the 5G system is exposed to the RG. So you could have a scenario where you have an RG that is wireline only, and it would manage its connections and configuration using 5G procedures on its control plane in band on that that wireline connection. It could be fixed wireless access only, in which case it's using 5G procedures there. Or it could be equipped with both, such as it's a hybrid access device. And it's using the combined 5G procedures to manage both how the dual accesses are used, the traffic distribution policy, etc. And that actually is a use case that's very near and dear to an awful lot of the operators out there. But sort of the key thing is it's not 5G on some interfaces and not on others, or the one interface it will dominate the others. That's all policy. The key thing is it's 5G on all interfaces that the device is equipped with and that their service subscription is configured to use. I hope that answers the question.
It answers the question a lot better than I could answer it, so thank you very much. Moving on to a next question, and Dominik and Venkatesh, maybe you'd like to look at this one. I understand that the QFI is assigned per each subscriber flow, correct? Can one subscriber queue contain multiple flows, i.e. multiple QFIs, and shared shape? These flows in the UPF or AGF, the specific subscriber. Dominik?
Okay, thank you for the question. So yes, this understanding is correct. Each flow has assigned QFI value, but those individual flows represent more individual services than subscribers, and each of them is related to some 5QI value. So that would mean that those virtual queues have different QS measurement parameters, for instance. So they might be different from one another. And but they can be put in a single access network tunnel, for instance. If you recall one of my diagrams, first the flow was created on the UPF level, and then on the radio access network node or in the AGF, the secondary tunnel, the data radio bearer or 5WE was created. So in those two tunnels, the QFIs can be matched into the same shared shape. But from the understanding of QS flow, those are differentiated services. So they should separate from the end-to-end point of view. I hope that answers the question.
Thank you, Dominik. Venkatesh, I'm going to ask you this one from this perspective. How is all the QoS RGLBack telemetry going to be provided to network monitoring systems?
Hey, thanks, Brent, for the question. So the QoS and the RGLBack, right? So if you look at them, they are pretty much parameters which are configured on a subscriber the way we do on the BNG. So when we translate this RGLBack, it actually translates you the QFI values to different shaping parameters, like what is the queue the particular QFI is going to map to, and what is the queue configuration at that point, right? So if you ask me the way the telemetry information will be provided, it should be similar to what we have in the wireline networks, or the information more granular at what you call as how the different cost is applied on the on the UPF, which is more at the session level, can be provided by the session. So I would say the telemetry would be split into two sections. One more at a PDU session level, which is provided by the RGLBack, and how the different flows are mapped to the queues and everything for the scheduler on the AGF. And the other set is where how the policers or whatever is the rate limitings which are applied on the QFI for the same flows on the UPF. I hope I answered your question, Brent.
Thank you, Venkatesh. And just to be clear, we've got a lot of questions coming in. So if we don't get an opportunity to ask all of them, we will type answers and make them available to you all. And any that we can answer, we will directly respond to you as well. But trying to continue on here, I love this because somebody's asking the moderator a question, Brent. So I'm going to ask this one because it gives me a chance to speak. Can you speak to any market research that is available showing the genuine interest by service providers to move to WWC, and how far out is this? So obviously from a Broadband Forum perspective, we're very neutral, but there are a number of surveys and reports out there in regards to the interest in WWC. We can't promote one against the other. There was a very good one out in December of last year from Omdia, but I want to stress that other reports are out there at the time. But I also think that another great indicator of genuine interest is by looking at the number of service providers that are contributing to this WWC work. First of all, 3GPP came to us and asked us to do the work. So that's all of the 3GPP community. But then openly available on the BBF site, you'll see some major contributors to it work, not just Deutsche Telekom and T-Mobile speaking here, but you'll see some of the major fixed and wireless operators getting involved in our work. In our release today, we have quotes both from Telecom Italia, Tim, and Vodafone, for example, in the press release. There are a large number of service providers getting involved in this work that shows genuine interest because they're the ones that are helping us drive this standards work. Brent, I hope that is as neutrally as I can answer that question. Okay, next question here, and Venkatesh, maybe you want to take a first stab at answering this from Kostas. Most of the examples showcase the mapping of PCP and DSCP to QFI and 5QI. These are only the identifiers. What about the convergence of the same type of scheduling shaping algorithms or congestion avoidance, i.e. WRED, in wireless and wireline systems?
Hi, Kostas. So as I understand that I was trying to just cover at a high level the RGLBack, but if we dig one level more into RGLBack, the RGLBack is actually providing you with the different scheduling shaping properties for a particular QFI. So the QFI being a common identifier end-to-end, the RGLBack breaks down the QFI to the relevant shaping, scheduling, or policers, or mapping the particular traffic to a particular queue, the priority of the queue, and all those details. So that's how what happens is once the RGLBack is applied or enforced on the AGF for that particular subscriber traffic, you will see the regular wireline costs like shaping and all these congestion cases wherein the WRED or you have WRR or whatever is your provided cost algorithms can be implemented and applied on the AGF. RGLBack, as I told, is providing you a spectrum of different values, which are pretty much everyone is optional, but each of them has a specific what you call as relevance, right? So for example, we have the DL downlink characteristics, which define you the different traffic classes, mapping to the queue, the priority, the rates, and everything, as well as you have a way to map to a policy which is predefined on your device. So again, QFI being an identifier actually translates into a different set of information provided by RGLBack so that you can achieve the wireline cost which is available to you today, but at the same or by providing what you call as end-to-end similarity or mapping for that particular subscriber traffic.
Thank you, Venkatesh. David, question here from Manikam for you. And I'll excuse me, Manikam, if I paraphrase it a little bit. Can you talk about how 5G slicing propagates into the RG, or does it not? Maybe not in the traditional AN plus CN slicing concept, but some level of service awareness and mapping to slices. Fundamentally, is WWC enabling end-to-end service awareness where end-to-end left, the WLAN and the WAN devices behind the RG are going all the way through to an AN, CN control, and eventually to the data network.
Yes. And now to elaborate on that a little bit. Because the 5G RG is a participant in the 5G system control plane, lifecycle management for access to a slice is extended down to the RG. And then we've gone further, we've embodied some of the RG connection management concepts into the TR-181 data model disseminated by TR-69-369 that allows non-3GPP devices in the home to map into slices and sessions and the basic constructs of 5G. And then I think there is also the ability to combine this with some of the smart RG work that is going on in the broadband services user group as kind of a force multiplier to start enhancing how all of this stuff integrates together to create a service environment. And then you throw network exposure in on the core network or the data network side of this. And it creates quite a powerful toolkit for service development. So the key thing is having extended the slicing concepts and the control plane to the residential gateway, and then using the TR-69-369 to extend it beyond that. So I hope that got the what Manikum was looking for.
Thank you, David. I've got a question here for Dominik from Michael. A home or business could have many devices. In that case, will the RG have a different PDU for each device and then multiple QFIs for each different flow? Will this require a very large number of queues to support all the flows across all the UEs? How many queues per RG would be expected?
Okay, thank you for the question. So first of all, we need to consider whether behind this RG we have the 5G capable devices or just regular devices like a, I don't know, laptop or television set. Currently, when the traffic is sent to your RG, it's just being rerouted, yes, to the standard devices behind it. So it would be the 5G capable device to decide whether it requires another PDU session, and it would be also to this device and also to some service owner, to decide whether it requires additional QFI flow, QS flow, sorry, for it with the unique QFI value. So it all depends on how many of these distinguished services you offer, and then whether the device needs a different parameters to realize the seamless service realization between itself and the UPF and the operator's side. We did not consider how many queues per RG would be expected. That's probably vendor specific, because there is also some freedom for the vendors to implement some logic into RG. But it's a very complicated session, and I cannot give you any number, unfortunately, for that. I hope that clarifies somehow.
No, thank you, Dominik.
Sorry,
go on, Venkatesh. Yes, please.
On the same thing, right? So when we were speaking to one of the operators, what we were told is they were looking at cases, two different possibilities, right? One is a single PDU session where the voice traffic and the video traffic and the best of traffic are mapped into 3 different QFIs, or there could be a case wherein each of them could be mapped into a PDU session itself, right? Now, in case of the case wherein you have all the 3 different types of traffic going on a single PDU session, that's where the prioritization, the shaping, scheduling is needed. But if a QFI is, what you call as, if, for example, you have an independent PDU session for video traffic for like a setup box connected behind the 5G RG, and you know that, okay, this is a specific IPTV case, then you really don't need the queues or the priorities, right? So depends on the use case itself, right? How the 5G RG will be deployed and in combination. So at least from what we see, the 5G RG would have at least a couple of PDU sessions. One is for management like TR69 or something like that, and one for the internet only, and one for what you call as IMS voice for sure. But again, this is pretty much extendable. By standards, you can have up to 16 PDU sessions, and each PDU session can have up to 64 cost flows. So pretty extensible. Again, can be defined by the use case.
Great, and I guess that answers Ayman's question in regards to the number of queue subs per subscriber on the AGF and UPF, Venkatesh. Or is there any? Yeah. Okay, we've got time for one more question from my old friend Gigi. Dave, I think you're probably the best person to answer this. And it's very, very opportune, I think, at this present time that we are seeing in the USA, but in other areas, some restrictions on 5G deployments due to a radio interference with aircraft radio antennas, as well as to close to heavy critical airports. This is creating a black hole. How are we solving that in this WWC work?
Well, the short answer is we aren't, because that's, if you're looking for, WWC is about wireline, which means it's not addressing mobile services. And if the issue is with respect to spectrum or coding interference for the delivery of mobile services in airport areas, then the wireline isn't going to explicitly help it. Now, to get away from making that too wildly negative a response, the corollary effort to WWC also relates to Wi-Fi convergence. So devices connected to Wi-Fi can use 3GPP procedures. You've seen examples of this already in the industry with Wi-Fi calling. And for areas like airport terminals and things, that does potentially offer a 5G solution. And in reality, there's an awful lot of operators that are also looking, in particular MSOs, that are moving into the mobile network space and are very interested in the Wi-Fi convergence aspects in order to expand their service footprint. So I think in terms of the overall convergence trends in the industry, you are seeing steps being taken that would probably provide some relief and extend 5G coverage in some of those areas that are hard to serve for whatever reason, be it an airport, be it a basement, etc.
Brilliant. Really busy and active Q&A session. We had, I believe, around about 20 questions, so I apologize if we didn't have time to get through every single question asked. But thank you very much. And once again, I just want to thank all of our panelists, Dominik, Venkatesh, and David, for a great session and webinar today. We have recorded the session, and if you opted in for further communications, we will send you a link to that recording, as well as a PDF of the slides that you've seen today. And we are planning a second Wireline Wireless Convergence webinar later in this year. So keep your eyes peeled in your email boxes, as well as on our website. We will be advertising that closer to the time when we will deliver another webinar in regards to all of the great work happening within WWC. So thank you so much for your time. And at that, I will just close the webinar. Thank you once again.